A rock is a coherent, naturally occurring solid consisting of an aggregate of one or more mineral species, or less common, glass or glass fragments. And a mineral is a naturally occurring solid that has a crystalline structure and a specific chemical composition. Basically, there are three classes of rocks. Number one, sedimentary, from sand, clay, or pebbles deposited in rivers or sedimentary basins, or chemical precipitates like salt or limestone. Number two, igneous, from magma, which can either be volcanic or plutonic. Number three, metamorphic, which are formed when pre-existing rocks, whether sedimentary, igneous, or even old metamorphic, are subjected to temperature and pressure. Therefore, a change in composition and or structure is going to follow. Geologists use the physical and chemical properties of rocks to distinguish and classify them, such as number one, the grain size of individual crystals, crystal aggregates, or fragments of older source rocks in millimeter or centimeter. Number two, the grain shape, whether it's equant, unequant, rounded, elongated, ellipsoidal, prismatic, sheet-like, etc. Number three, mineralogical composition, in terms of which mineral species form the rock and how much of which species is there. Number four, chemical composition, in which the rock is chemically analyzed to determine its chemical components, usually the percentages of oxides like SiO2, Al2O3, K2O, FeO, MgO, CaO, etc. are determined. Number five, texture and structure, and here the relationship between the mineral crystals or aggregates that form the rock is examined. For instance, in some rocks, the crystals or aggregates are randomly associated, while in others they are aligned, clustered, layered, etc. It's always a good idea to describe the overall appearance of the associated surface or subsurface rock units as well, including all of the topographical, geological, and structural information.